Welcome, ladies and gentlemen. Today we're going to talk about using trigonometry with right triangles. You're going to need a calculator, a pen and or pencil, and of course your notes. Alright, our goal for this is to extend our knowledge of trigonometric functions beyond the three basic ratios. So, ladies and gentlemen, this is very, very important that you get all of this written down, please. These are the 6 trigonometric functions or trigonometry ratios. All right? You're going to want the picture. And now remember, ladies and gentlemen, this symbol right here that you're seeing, this right here, is theta. It's just like A or B. It's just representing the angle. Now, the 3 that we know, sine, cosine, and tangent. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. If we see to the right, these are just their abbreviations. This is how we can abbreviate it when we're writing them out. We're very comfortable with these. We've used these a lot. Now I'm going to add 3 more, and these 3 new ones are the inverses, or the reciprocals I should say. They're the reciprocals of sine, cosine, and tangent. I have cosecant, which is hypotenuse over opposite, and it's going to be abbreviated like this, CSC theta. I have secant, which is the opposite of cosine, which is hypotenuse over adjacent. And I have cotangent, which is adjacent over opposite, which is the reciprocal of tangent. And we can represent it like this, cotangent theta. We can also think about it as it being 1 over sine, 1 over cosine, and 1 over tangent. All right, very important. Please have all this down in your notes. You're going to be referencing this a lot. Okay, all of this must be down in our notes. We're going to do 3 examples with this. Here's our first one. On our first example, it says evaluate the 6 trig functions of angle theta. So here's angle theta. Before we can even evaluate our 6 trig functions, we have to find our missing side. In order to do that, we're just going to do Pythagorean theorem. So I have x squared plus 15 squared equals 17 squared. So x squared plus 225 equals 289. To solve this, we're going to subtract 225 on both sides. And x squared is going to equal 64. Square root both sides, x equals 8. So this side length right here is going to be 8. Now, before I even get going, I'm working with this angle. I'm working with angle theta. So I'm going to label my sides. This is the opposite, this is the adjacent, and this is my hypotenuse. Now, I can identify my 6 trig functions. So all we're going to do is plug in what we know. So if we think about this, sine we know is opposite over hypotenuse. So if we use that angle, the opposite is 15 and the hypotenuse is 17. And there's our answer. For this next one, we're doing cosine. To find cosine, it's adjacent over hypotenuse. So our adjacent to that angle is 8 over our hypotenuse, which is 17. Now, tangent is opposite over adjacent. So opposite is 15 over adjacent, which is 8. Now, here come our 3 new ones. Starting with cosecant. Now, cosecant is the opposite of sine. So if I want to think about this one, these ones go together, the opposite. So I'm going to have hypotenuse over opposite. So I'm going to have 17 over 15. Next one we have is secant. Now secant is the opposite of cosine. So it's going to be hypotenuse over adjacent. So 17 all over 8. And last but not least, tangent is the opposite of cotangent. So cotangent is going to be adjacent over opposite. My adjacent is 8, and my opposite is 15. So this is what it's going to look like when I have to rewrite my 6 trig functions. Alright, moving on to our second example. This is very important. You're going to see a few of these, so make sure we get it in our notes once again. We're going to let theta be an acute angle in a right triangle. What are the values of the other 5 trig ratios in the triangle? So we know that if I draw a right triangle, and I label this angle theta, and if I'm talking about cosine, now remember, cosine is adjacent over hypotenuse. So my adjacent to theta, which is right here, is 7, and my hypotenuse is 10. Now before I can identify my other 5 trig functions, I need to find my missing side. So I'm going to have x squared plus 7 squared equals 10 squared. X squared plus 49 equals 100. Subtract 49 on both sides. X squared equals 51. Square root both sides. This one, x is going to equal the square root of 51. So here I have the square root of 51 for this side. Now that I have my triangle filled out, I can finish filling out the rest of my trig ratios. So I know before we go, this is the opposite, this is the adjacent, and this is the hypotenuse. Now, sine is opposite over hypotenuse. So if I look at this one, opposite is the square root of 51 all over my hypotenuse, which is 10. Now, cosine is adjacent over hypotenuse, so my adjacent is 7 all over 10. And my tangent is opposite over adjacent. Opposite is square root of 51. My adjacent is 7. Now we have to think back. I'm back at cosecant. So when I'm working with cosecant, it's the opposite of sine, so these ones go together, so it's going to be hypotenuse over opposite. So my hypotenuse is 10, and the opposite is square root of 51. But we're not done here because we can't have square roots on the bottom. So I'm going to multiply both the bottom and the top by the square root of 51. So I get 10 square roots of 51 all over the square root of 2,601. Now the square root of 2,601 is a perfect square. So I get 10 square roots of 51 all over 51. Alright, it's very important, ladies and gentlemen, we can't leave square roots in the bottom. Moving on, we have secant. Well, cosine and secant are opposite, so it's going to be hypotenuse over adjacent. My hypotenuse is 10. My adjacent is 7. And last but not least, tangent and cotangents are opposite, so I have adjacent over opposite. My adjacent is 7. My opposite is the square root of 51. Once again, can't have square roots on the bottom. Square root of 51 on the bottom and the top. Now, if you guys have noticed, when we do this, I'm going to have 7 square roots of 51. And on the bottom, it always ends up being the same number that was being multiplied times each other. So I'm going to write 51 right away. And there's our answer. There are 6 trig ratios. Alright, ladies and gentlemen, last example for the day. So make sure we get this in there. We're going to be working with a 30-60-90 triangle and a 45-45-90 triangle. So you're going to want to get both of these triangles down because we're going to be answering some questions about both. Our goal here is to find the exact values of the sine of 60 is our first one. So I'm going to come over here to 60. Now, sine Sine is opposite over hypotenuse. So if I look at this, my opposite of this is square root of 3. So I have a square root of 3, and my hypotenuse here is 2. So it's going to be the square root of 3 over 2. That is my answer, ladies and gentlemen. That's it. That's done. Now our next one, I want to find the cotangent of 30. So now I'm working with 30. So this is my opposite, this is now my adjacent, and this is still my hypotenuse. Now it's very important, cotangent is adjacent over opposite. So my adjacent is the square root of 3 all over the opposite, which is 1. So my answer is just going to be the square root of 3. And last but not least, I have the secant of 45, so I'm going to move over to my 45, 45, 90. I'm going to pick one of my 45s. This is opposite, adjacent, hypotenuse. Now secant, remember, hypotenuse over adjacent. So my hypotenuse is square root of 2, and my adjacent is 1, simplifies to the square root of 2. Now please make sure, ladies and gentlemen, that you got all of the notes down for today. It's very important. I hope you have a wonderful, fabulous day, and I will be seeing you later. Have a good one. Bye.